Thank you.
Please.
So it's very nice to be a part of this conference. Today we will be speaking on fractal-like structures in Indian temples. So my name is Sreeya. I've worked with Sandip and our mentor, Bhabatosh Chanda, on this project. So we will be discussing some fractals. What are they? And then Indian temple architecture. We have different types of temples, and we are going to discuss mainly on the spires of the temples. There are rich artworks available in the spires. So we will discuss some self-similarity on them. And then we're going to calculate the fractal dimension. We have used box counting method for counting the fractal dimension of the spires. And then we have applied our method for various types of temples. So let's just start with that. So what is a fractal? It is a pattern. It's a symmetrically expanding pattern which exhibits self-similarity. You can see fractals in nature, like we have in a fern leaf, or we find it in Sierpesky triangles, or maybe in Mandelbrot sets. They are recursive patterns across different scales, such that any small portion resembles the whole. So the term fractal, this was first coined by Benoit Mandelbrot in 1975. It comes from the Latin word fractus, which means broken or fractured. He used these to extend the concept of fractional dimensions to geometric patterns in nature. Mandelbrot actually tried to calculate the length of the coastline of United Kingdom. So he applied a fractal dimension to do that. So these are pictures of some fractals in nature. In fact, we find fractal everywhere in nature, from meandering of the rivers to fern leaves, even our lungs, the alveoli structure, the iris of our eye, and starting from cauliflowers, sunflowers, many things. Now let us come to Indian temple architecture. The concept of temple architecture aims at inspiring a sense of infinity, sublime beauty, unity in diversity, and everything divine. So we find normally the temples are vast, they are symbolic, and they have embedded repetitive fractal designs. I don't know if you can see the full picture. Okay,
Yes, we can.
Okay, so a temple can be compared to the figure of a Shiva, or maybe any human figure, where the spire is basically the portion of the head of any human figure, or here we have represented it with Shiva's figure. Shiva is a god, the deity of Indian temples. The main deity we consider Shiva to be one of the main deities. The body is of the sanctum where the deity is placed. So now we are here, we will be considering mainly the spire or the top portion. Mm, Geometry plays a very important role in the construction of Indian temples. By geometry, I basically mean Vedic geometry. These geometries have been discussed in our old texts. The texts are known as Shilpa Shastras and the Vastu Shastras. The Shilpa Shastras, Shilpa means art in Sanskrit. So the texts which deal with arts and crafts are known as Shilpa Shastras, and Vastu means building, architecture. So the texts which deal with those are known as Vastu Shastras. Shastra means text, basically. So over the passage of time, Indian temple architecture have evolved from caves to palatial temples. On the left, we can see one of the sketch which was used as a fresco painting on the Ajanta caves. The Ajanta and the Ellora are very famous cave temples of India. They have been considered as one of the heritage sites by UNESCO. Now, they were built in almost 2nd century BCE. So they are very old. And the below one is a wood carving based on the Ajanta paintings. Then we also have another similar cave temple, the Elephanta Caves. These are found on the western side of India. The state is known as Maharashtra. These were also built around the 2nd century BCE. From then, we have been having different sorts of temples. Architecture have evolved over time, and the right-hand side is our very newest one. It's the Akshardham temple in our capital city. New Delhi is the capital of India. We have this temple over there. It was consecrated around 2005. Now let us come to different types of temple spires. Basically, we will find fractals everywhere around in the temples, but for now, we are going to concentrate on the spires. And we have analyzed these from a viewer's point of view, not on the geometry, rather, not on the geometrical plan of the temples, but as a viewer would view the temples from the images, we have analyzed ourselves. Now, these are mainly 3 types of different architectural styles, which are very important architectural styles. We have many more regional architectural styles, but the main 3 main styles are the Nagara styles. On the left one, Nagara is the North Indian temple styles. In North India, we will find many temples, or mostly all the temples will have such structure of spires where it will be slightly dome-shaped, symmetrically rising, and it will culminate in a point. The second picture is of the Dravida. Dravida is the South Indian architecture. This is basically pyramidal in structure. So there's a difference of shape between North Indian and South Indian temples. And then we have the Vesara architectural style. The Vesara is the Central Indian architectural style, which is basically a mixture of both the North Indian and the South Indian style. So the spire is above the main sanctum enshrining the deity. The sanctum is known as Garbhagriha. Garbha means the womb. In Sanskrit, Garbha means womb. So the concept is as if the deity is there staying in the womb. So that is the concept of the temple. And the spire rises above. Now let's come to the North Indian Nagara style spires. We can see from the picture, the spires are, the designs are very similar to each other, and the similarity is along the vertical panels. The name of these North Indian spires are known as Shikhara. Shikhara is a Sanskrit word which means peak, mountain peak. So, like the structure of a mountain, the mountain normally rises symmetrically and it peaks to a point. The North Indian temples also resemble similar features. So, hence the name has evolved. We have the similarity of patterns along the vertical panels over here. In contrast, the South Indian temples have similarity along the horizontal panels. The South Indian styles are known as Dravida style, and the spire here is known as a Vimana. Vimana means an aeroplane. So the concept is the deity can as if fly about in this from the spire will help the deity to fly about wherever he wants to. So here the Vimana style has similarity along the horizontal panels. Now we have like that, we will have similarity in all other types of spires also. We can observe the similarities. Here I have not discussed in details the other styles. So now let us come to the concept of a dimension. The dimension in common language, it's the measure of the size of an object which requires the minimum number of coordinates to specify any point within the Euclidean space. So a box needs 3 coordinates to define it. We need the length and the width and the height. So a box has 3 dimensions. Likewise, a point is 0 dimensional, a line is 1 dimensional, a square is 2 dimensional, and so on. Now, those were the integer dimensions. Now, let us come to fractional dimension. Suppose we take an object residing in the Euclidean dimension d and then reduce the scale by a size of 1 by r. Then the measure, the length or the area of volume, that would increase to n. N is equal to k times r to the power d, where k is some constant. Now suppose we have the diagrams. Suppose we have d equal to 1, we have a line, then in 2 dimension we have a box, we have a square, in 3 dimension we have a box. Suppose we divide the line into 2 parts. So r is over here 2. We take the scale to be half of it. Then the number of boxes would increase. So n will be 4 if we reduce the scale accordingly. The number of grids would increase. So the relation from the relation, if we put 1 by r to be e, just for the sake of symbols, then we will get n is equal to k into 1 by e to the power d. Now if we want to solve that, this d is our dimension. If we want to solve this d, we have to insert log both sides. Natural logarithm we will apply to it. And then we will get the relation d is equal to log n by log 1 by e minus log k by log 1 by e. Now the right hand portion log k by log 1 by e tends to 0 as our size r or 1 by e tends to 0. As e tends to 0, our right hand side log k by log 1 by e tends to 0. So now d can either be an integer or a fraction. If it's a fraction, then the concept of fractional dimension comes. Now this is the box counting method which we have applied to our results. Now what happens is we take any pattern and then we cover the pattern with grids of boxes in the first step. And then we're going to go on to the next step. We reduce the size of the box to half, and then we again cover it. And we go on doing this process till we feel that we can cover all the finer aspects of the patterns very minutely with the boxes. We have already seen what is fractional dimension. Keeping that in mind, here we apply the same concept for box counting method to find the formula. To that, if we apply the size of box, the size e to be tending to 0, then we take the limits, then d equal to limit as e tends to 0 log n by log 1 by e. That is my fractal dimension. Here n is the number of boxes that are needed to cover any pattern, and e is the box size. So the negative slope of the plot of log e versus log n versus log e gives us the fractal dimension. Now this is the result which is there already. The box counting formula for the box counting algorithm. It's a known formula. We have applied that to calculate fractal dimensions of different temple spires. So what we have done is we have considered it from a viewer's point of view, and then we have taken the image of a temple spire. We have converted the color image to a grayscale image, that is basically a black and white image. And then we have calculated the gradient using a method called Subel filter. It's basically a filter we use to measure the difference of intensities of pixels. So that gives me the gradient. And then we have used a method to determine the edges in the picture, in the gradient, edges in the image of the gradient. And then we have applied some threshold. We have taken a threshold to be mean of the pixel intensities, and we created a binary image. A binary image means an image which is having only 0 and 1 values. To our binary image, we have applied the box counting algorithm. So a binary image is then covered with grids, so of sizes to the power n, and then we go on decreasing the size of the grid at each step till we go to 2. And as we said before, the number of boxes, if we plot along y-axis and size of the box along x-axis, Then the negative of the slope is the box counting dimension. So we have been speaking too much theoretical for the last few minutes. Let's look at some pictures. So it will be a bit interesting. So what we have done is, to the binary image, we have taken a grid. On the left hand side, we have taken a big grid and then counted the box, and we have found out the dimension, fractal dimension there. Then again, we have repeated the process by diminishing the grid size and got the middle picture. And further again, we have done it. We have repeated the process from 2 to the power 9, grids of size 2 to the power 9 to 2. The image on the left hand side has 256 pixels. Then the middle one is with 64 pixels. And the one on the right hand side has 16 pixels. And that was our work which we have done behind. Now, let's see some pictures on which we have applied our results. These are some North Indian temple spires. This is the Kandarya Mahadev, the Rameshwara, the Lakshmana. On all these, we see the spire is symmetric and slightly dome-shaped, which rises symmetrically above. Here we see the fractal dimension, which will be obviously a number something between 1 and 2. If we have numbers nearing 2, which means fractal dimension is quite high, which reflects that there are many fractal-like features present. So we find that in the North Indian temples, we have fractal dimensions ranging from 1.8 to 1.78. Now the same thing we have done for our South Indian ones. Here we have taken Meenakshi temple, Priyadeshwar temple, Murugadeshwar temple. Here also our values have varied from 1.79 to 1.73. Now coming to the Vesara temple spires, we have actually applied our results for the spire portion. We have given the picture of the whole temple and there's a gap in between to mark that the spire is different from the base of the temple. We have had our results on the spires, not the base, but we have given the picture to make you, to give you a feel how the full temple looks like. So the temple spires here have also very high fractal dimension. It's from 1.77 to 1.85. Similar thing we have in the East Indian Bengal style. This is not a main architectural style, but it's a regional architectural style. It's very specific to a specific East Indian region, the region of Bengal, from where we belong. So we have temple spires of this sort. Here the spires are known as Ratna. The number of spires are the name comes from the number of spires of the temple. If the name on the left hand side, we have the Pancharatna. Pancha means 5. We have 5 spires, so it's Pancharatna. And on the right hand side, we have 9 Ratnas, 9 spires. So 9 means Nava in Bengal. So that's Navaratna. Here also we find that the value is above 1.7. Now we have also applied our result to some other monuments, like we have applied to church spires. These are Notre Dame, the St. Stephen's Cathedral. They have rich work, but the fractal dimension is lesser than that of temples. Maybe architecturally they are rich, but the spires are not as rich as the temple ones. So we have their values to be slightly lesser than 1.7. Normally for churches, we have seen that they vary from the range 1.5 to 1.7. So we have the Notre Dame, the St. Stephen's Cathedral, the Basil's Cathedral, and St. Peter's Basilica. We've also applied a result to some mosque spires. The mosques, since they are more or less plain, the spires, so their fractal dimension is lesser than that of temples or churches. It falls normally in the range below 1.5. So here we have done a comparison of the values of the spires, fractal dimensions. We have seen that normally temple spires have very intricate works, and self-repetitive patterns are very much observable in temple spires. Hence, we have fractal dimensions for them to be above 1.7. For the churches, they are 1.5 to 1.7, and for mosques, they're below 1.5. So that was our conclusion. So we found that fractal features and self-similarity in different variants of Indian temples, and fractal features vary depending upon the architectural style. One thing I should also mention, it also depends on the quality of the image. If the light and the quality of the image, how sharp, how blurred it becomes, the fractal dimension can vary, because everything depends upon the pixel quality. So the fractal dimension here is calculated from the images as seen from the viewer's point of view, and structural complexity from the viewer's perspective. And we've observed that the Indian temple spires are quite rich in fractal features. These were some of our references. Thank you.
Thank you. Thank you very much, Sreeya. Sreeya, I was wondering before giving passing the questions to the audience, if you considered, instead of using images, performing photogrammetry from to model the topology of the tower's temples to obtain more accurate results.
Or from the images that we have applied actually line diagrams. We have converted them to we have converted them to gradient variations, and then we have applied line diagrams using edge detectors like canny edge detector. So on the line diagram, we have actually analyzed, not the raw image.
So I was thinking that probably photogrammetry will help you to obtain more accurate models and more accurate results as well.
Okay.
Thank you.
Thank you. We will consider that.
Okay. Could you stop sharing the screen, please, so that we have the audience? Thank you. Does anyone have a question for Sreeya? Yes, Dennis, go ahead.
Thank you very much. I enjoyed very much your lecture. I have very many questions, but maybe we should discuss it later. Theoretical question about Sanskrit. What is the meaning of Vimana?
Okay, Vimana means an aeroplane.
No, this is my problem. This is my understanding, but maybe it means birds as well, because the temples are definitely older than the aeroplane was discovered. What do you think about this?
Well, we have mentions, if you have heard about our old scriptures called Ramayana, where
Yes.
we have so Ramayana, there we have mentions about the Vimana, the Pushpak Vimana, which Ravana used to, come to India, come and usurp Sita. So that there was a concept of Vimana there. That was the vehicle which Ravana used to move on.
Oh, so it will be like flying vehicle, because
Yes,
in many
flying
cultures,
vehicle. Yes, it's a flying vehicle. So that was his Pushpak Vimana.
And my question that in the Shurba Sutras or the Kshetra Ganita, are there these methods described in some level?
In the Sulba Sutras, we have mentions about the structure, not the, the bird structure and all we have, but not what we have discussed today. That what we have discussed today is in the Shilpa Shastras. The
Shurba
Sulba,
Sutras. Yes.
Shilpa Shastras. The Sulba Sutras are a different kind of text. We have many texts, so that's a separate one to discuss on geometry and principles, separate sorts of principles. Yes, all are Vedas. They are different sectors of Vedas.
And one more question about, it was very nice that you made geographic description, that North India, South India, Bengal, and so on. But did you consider the differences in the religions of India? That, for example, Buddhist temple and Hindu temple. So Marcin has the same question. I give you the floor.
Okay, Buddhist temples, normally the structure is of a stupa, which is nearly planar. They have lesser structures above it. But if you consider, I have shown you the cave temples of Ajanta and the Elephanta. They are basically Buddhist architectures. If you consider the pillars among the caves, they will have depictions and pictures of Buddha, the carvings of Buddha, rather than the spires. Since here we have discussed about spires, I have not considered that part. The spire, if you talk about, that's a stupa. That will have lesser fractals. But if you get into the caves, the pillars and the doorways, they will have rich fractal designs in it.
But how it is in Patna? Sorry.
Okay, like I showed one picture of Ajanta, one wood carving. That is basically one story of the Buddha's. Buddha used that as a preaching, a story of an elephant, of 6 elephants with tusks and all. That is basically a Buddha story.
And last but not least, I have 2 comments, just very short comments. That the first one is that I recommend you a Berkeley paper. That was a very distinguished Berkeley mathematician called Siedenberg. And he published in the 1960s, I will give you the reference, a few papers. And one of his papers is about the ritual origin of mathematics. And he also studied Indian geometry and Indian culture. It is very interesting, I believe. And the second comment is the following one, that, or maybe it is a semi-question or comment. Do you work with people who are restoring buildings? Because your findings is very important for heritage conservation. So when archaeologists or architects approach you when they would like to reconstruct something, maybe your methods or your data are very useful for them.
Yes, presently we are working on a heritage project itself. we have a separate body in India looking after the archaeological structures. They are the Archaeological Society, and they provide us with some data. So we try to analyze them and restore them digitally. That is our current work.
Thank you. Thank you very much.
Thank you. It was very nice to present here. Thank you.
Thank you.